Hi, and welcome to this video tutorial. And what we're going to talk about today is simple circuits. So why don't we just dive right in? So a simple circuit, let's see. This is a picture of a circuit board, and I'm sure that you've all seen something like this before. And what I want to do is start trying to explain a little bit about what a simple circuit is and how we can express that in drawings and understand how they operate. So we've talked about the flow of electricity, and the flow of electricity is passing electrons between atoms in a conductor like copper or gold, that an energized electron enters a copper or gold atom, but it can't stay there because it doesn't have as many protons. It's unbalanced. And so what it does is it kicks it out and sends it down to the next electron, and that atom becomes unstable, and so it kicks out the electron again, and they just keep passing electrons around a path. It is a flow of electricity, and that path requires two wires. We're going to send electricity out one conductor, and it'll go to a load. That load then consumes it, and then it has to have a return path. So a path has a send and a return, and any electrical circuit requires at least two wires from the power source, that send and a return. Right? So there are several basic components to an electrical circuit, and the first is the power source. You could think of that as a battery, maybe a battery in a flashlight, or a battery in your car, a battery in your TV remote, a battery in your cell phone. That is the power source. Inside of a battery, there is a chemical imbalance, right? So the chemical composition of a battery means that one side has a surplus of electrons and the other side is balanced or neutral. And the electrons are going to flow once a circuit is made. They would flow from the surplus of electrons to the area where they're neutral. An electrical power source is always trying to achieve balance, right? So that's the power source, the battery. Right? The other thing that we need is the conductors, right? And not train conductors. We're talking more about wires. And the wires contain the metal, either gold or aluminum. I guess sometimes they could be silicone, but typically metal and wire that is going to allow the electrons to flow through their path. The next thing that's important for an electrical circuit is a load, right? Whether that's a light bulb or a motor or some other device that's actually going to consume and regulate the flow of an electricity. The electrical circuit will not consume or use more power, more electrons, than what the load needs. So it very much serves as a regulator for that flow of electricity. And the next component I'll talk about is a switch. And a switch is a way to turn on or off a circuit, right? So you can see down in our diagram that when our little switch is open, this pathway is broken and prohibits the flow of electricity. When our switch is closed, it allows the flow of electricity and our light bulb illuminates. That open, did I do that? Let's back, right? So that idea of open and closed, right? The path for the flow of electricity. An open switch versus a closed switch, right? So let's go on down and let's look at our, so I'll actually pause here. That's a good place.